All right, hello everybody. This is our May Steeltoe community meeting. I will paste the notes here if anybody wants to see what the agenda is today. We do have some good news. We did release the Steeltoe 3.10 RC1 just this morning, actually, which has our new Steeltoe stream functionality with RabbitMQ. We also have support for Spring Cloud data flow. We added a new Spring Bootstrap auto configuration feature, which is also there. And then we also have a bunch of other fixes. So feel free to take a look at the notes, the agenda notes, is all that's on there. It's also on our website, and the release notes are out there too. Got a pretty good turnout today. Let's go ahead. I think one of the main things we wanted to do is, just go over some of the project open issues. Obviously, if you look at let me share my screen actually. All right, so we have our good first issues. Obviously, for the community, if you want to take a look at anything that's might be easy to get started on, just click on that link. We also have some help wanted, which is kind of one and the same, but you can click those too. Sometimes they're not as easy. They're a little bit more difficult or challenging. So we're definitely looking for help from the community to assist with us. And then, our upcoming releases, like I just mentioned, we had release candidate 1, which is now available. We have 3.1.0 RC2 planned for likely in 2 weeks from now. That's typically what we do, release 1, and then 2 weeks later, RC2, and then if everything goes well, we'll have our GA by another 2 weeks after that. We do have plans. Like right now, we do have some limitations to our streams functionality, which we'll get into in a little bit here. But for our RC1 anyway. But once GA, we should have a full featured stream functionality. And most recent releases were the 2.5.3 and our 3.02. That was in the beginning of the year. A couple other things, some new events are coming up. We got Spring 1 in September. We also have VMware World. I'm not sure what the date was on that one. I think it's around a similar time. I'm not 100% sure on that one, but you can check the website. And I guess if there's any questions, feel free to raise them, or we can just jump into starting to take a look at the new features of 3.1.0. Any questions, or anybody else on the team want to give an update or anything before we get going?
I'll mention something about the book. Okay. That is continuing. Our contact at Packet, he is in India, and they have obviously had some challenges in the country. So I just kind of laid off pushing him into getting anything content to us or anything like that. So anyway, he's gotten back to me. I started filling out the I don't know what it's called, but basically the whole sheet about what is the book, what is the working title, what are all the different sections of the book, filling all that stuff out. I began filling that out. He looked at it and said he'd like to have some time to talk. So we're working on something for Friday to talk a little further. My intention there is as we get down the layout of the book, and he's good with that, so then we get in to start writing the content, then I'll start tagging some of you guys in docs for each of the different areas or chapters or however it falls out. That's it.
Sounds good. I believe was everybody still interested in moving forward on that? I know that you were getting, I guess, the outline ready, David. Sorry.
Yeah.
Okay. All right, sounds good. Anything else before we get started? All right, let's go ahead and discuss our new features here for 3.1. You want to start, Dave?
Yep.
Tillman? Yeah. Okay.
So let me. So what we did in 3.1 RC1 is we finally got our streams code out, which has been a long time coming. This is code that builds on the messaging work that we did back in 3.0. So we released messaging support in 3.0 of Steeltoe. And that was, the idea was that we wanted to support another type of, another way of writing microservices that is, that we didn't support in the past, and that is basically message-based microservices. Of course, we've had great support for kind of REST API-based microservices with all the features that we have in Steeltoe, with service discovery and circuit breakers and all kinds of stuff. But we didn't really have anything related to building message-based microservices. And so in 3.0, we introduced some new programming model related to and abstractions related to messaging. And so I think it might be worthwhile to look at that just to kind of recap or review that, because that will help put in context what we did with the streams-based programming model and what it adds in addition to what we did in 3.0. So let me share my screen, and I'm just going to use the documentation website. If I can find it here, let me see. I think it's this one. So hopefully you can see, I'm just on our regular steeltoe.io website with documentation, and I'm in the messaging section. And there's an intro messaging RabbitMQ section in there that shows an example of kind of the programming model that we implemented with some of it, not all of it, but how easy it is to write a message-based microservice using the Steeltoe messaging infrastructure. So what we've got here is a class, a program class with main, and in it, of course, it creates a generic host builder and builds it and then runs it. And then we can, in the method that creates the host builder, we add some core messaging services. And as I said, what we did was in the 3.0 timeline, we introduced some abstract API kind of stuff that we think is applicable to all different kinds of messaging systems. The first one that we implemented is RabbitMQ and support, but we implemented things like an iMessage header. We implemented message converters. We implemented something called a message template. And then we actually, and these are all kind of abstract types and classes that we have within the messaging infrastructure. And then we implemented actually concrete implementations of those specific to RabbitMQ. And so what I'm showing here is an example of how you can use those APIs in building a message-based microservice. And so you build up the container, a generic host container, you add the core RabbitMQ services as shown here. And then optionally, if you want to interact with the RabbitMQ broker as an administrator, meaning the ability to create queues, create exchanges, those sorts of things, then you also want to go ahead and add the Rabbit admin client into the service container. And then if you're going to send and receive messages as a client, then the next thing you probably want to add is the Rabbit template, because it provides a nice, easy abstraction for interacting with the Rabbit message broker for sending messages and receiving messages, that sort of stuff. And then if you want the Steeltoe infrastructure to actually create a queue for you, or to ensure that a queue, for example, is already created on the broker, and this also applies to exchanges, to bindings, etc., then you can also add those into the service container as well when you start up your application or configure your application. So in this case, we're adding a RabbitMQ into a RabbitMQ queue into the service container, and it's got a name called MyQ. And what happens is, because and when we start the application, what happens behind the scenes is, because we've got the Rabbit admin in the service container and we've got a queue defined in the service container, the Steeltoe infrastructure upon startup will actually go out and ensure that queue is configured and up and running. And in fact, what happens is a little bit later, I'll talk about this thing called a RabbitMQ container. And this is not to be confused with like an OCI container or a Docker container. It's an internal data structure that we use behind the scenes to configure the listener, the thing that's going to handle the interactions with the RabbitMQ service broker. That listener will actually constantly check to make sure the queue is still out there. And if for some weird reason the queue is deleted, or the exchange is deleted, or the binding's deleted, the container will actually go out and make sure those things get redefined so that the application continues to run unimpeded. Then in this case, in this particular sample, we're going to also add what's called a Rabbit listener. Basically, it's a POCO object that we're going to add into the service container, and it's going to be handling incoming messages, processing incoming messages off the RabbitMQ broker. And then we've got to tell Steeltoe about that listener. So this basically just adds the service object into the service container, and this tells the Steeltoe infrastructure about the particular listener. And then last thing we do is this is basically, we're going to set up a process to run in the background that's actually going to send messages to the broker, so that the thing that we're going to listen for, the listener is going to actually be able to receive them. So this is kind of a background message, a message sending piece of code. And so then down here where we define our listener, we just define it as a regular POCO object, and then we add an annotation or an attribute to a method. And there's lots of ways in which you can do this, but this is the simplest way. We add this annotation or attribute to this method called listen, and then the name of the method could be anything. And essentially what you're saying is you're telling the Steeltoe infrastructure that I want the underlying container, the RabbitMQ container that is processing and interacting with the RabbitMQ broker to essentially bind or connect this method, this listen method, with that particular queue called myQ, so that behind the scenes we will automatically spin up this container, we'll connect to the RabbitMQ broker, and we'll begin to process and consume any messages that come off that queue, and then invoke this method called listen. And behind the scenes, we'll even do message conversion. So with the message that comes off the queue, we'll look at the content type, for example, of the header that's in the message. If it's for example, if it's a JSON-based encoded message, and say it's a person object, we'll actually, and you've defined the person object, in this case, we just have a simple string, but if you've defined a person object on this method, we'll behind the scenes do the message conversion, create the person object, and do the marshaling of the data off the message that comes in, and invoke this method for you to do whatever business processing that would need to be done. This other component down below here, this Rabbit sender, this is just a hosted service. It starts up, and all it does is creates a timer and then starts sending messages using that template that we get injected or that we get out of the service container, pull it out, set it up, and then we just basically convert and send to the myQ a message. So that was some of the infrastructure that we put in place in 3.0. And as you can see, it's very Rabbit centric, but in the future, you can imagine the same programming model, everything that I've just described, being applicable also to, say, for example, Kafka. And we've got on our roadmap at some point in time down the road to try to implement the same kind of infrastructure for a Kafka-based system as well. So then what we did, and so this very simple set of infrastructure, although under the covers it's pretty complicated, allows you to create basically a microservice, deploy it, and process messages that come in off of a RabbitMQ based message broker. Pretty straightforward. So then what we wanted to do is we wanted to take this to the next level, which is now to add another layer of abstraction on top of this to completely isolate you from the underlying messaging infrastructure. And that is what is essentially the streams-based infrastructure that I'm about to show or illustrate. And so this builds on top of the RabbitMQ stuff that I've just been showing you. But it also then fully isolates your application code from the underlying messaging middleware that's sitting underneath it. And it also enables another type of application that you can build now with Steeltoe, which we wanted to enable as well, which is commonly called a data processing pipeline type application. And these are applications that typically process streams of information, streams of messages, you could think of it that way, maybe do some analytics on that. They may be more of an ingest kind of application where you're getting a bunch of data from some location and you want to ingest it into, say, some backend database or some set of backend databases. And there's a bunch of processing that needs to be executed against that stream of messages that come in, and then the results and the results of processing those events or those messages can then populate databases or invoke other microservices or whatever. And so the streams infrastructure that we're providing in 3.1 RC1 supports those kinds of applications, as well as it still enables this other type that I've just described, where you're creating a message-based microservice as well. So let me switch over to the streams documentation, and I'll just see if I can show you. Here is now what a streams-based microservice would look like for processing messages. So we introduce another level of abstraction on top of what we did, but the programming model is very, very similar, as you'll see. First of all, one of the things we did is we introduced a host called stream host that is used to essentially configure the underlying service container. And it's based, I think if I'm correct, Han and Neil will explain this probably a little better than I can, is based off of the generic host. So you get all the same basic service configuration, service container configuration that you get with the generic host, but you also get now the streams, the Steeltoe streams-based components auto-configured into the host for you at startup time. And there's some new annotations or attributes that we've added that essentially begin to add this additional layer of abstraction that as a developer you get to take advantage of. First of all, the one at the very top is this thing called enable binding. And what this does is it signals to the Steeltoe framework. There's three off-the-shelf bindings that we provide, and you can also configure your own as well. But the three that most common that are used are what's called a sync binding, a source binding, or a processor binding, and they're all prefixed with iSync or I because they're all interfaces. So iSync, iProcessor, and iSource. And what this does is you can enable bindings, and so a sync, for example, is a receiver of incoming messages or events. And a source, of course, is something that produces outgoing messages or events. And then the processor is a combination of both a sync and a source. And so this level of abstraction, then, we automatically, behind the scenes, will automatically bind that to a underlying messaging infrastructure. And so, and the way that's done is there's this component now that we've added called a binder, a messaging binder or a channel binder that sits underneath that essentially you have a binder for various types of middleware that are various types of messaging infrastructure out there today. The only one we have today, of course, is the RabbitMQ one, because it's built on the stuff that I just talked about, the RabbitMQ messaging technology that we introduced in 3.0. But the binder is responsible for wiring up, if you will, and auto configuring anything that needs to be done on the RabbitMQ message broker. And we, the Steeltoe framework, we automatically detect what binder is included with the application, and then we will invoke that binder to do all the hard or heavy lifting of, say, configuring queues or whatever needs to be done on the underlying messaging system in order to implement this, for example, this iSync. And then down below, so that was the main thing that we added as an abstraction. And then down below, we now have this thing, instead of a Rabbit listener, we now have what's called a stream listener. And we essentially say, okay, we want this method handle, which is going to receive person objects, to be bound to this binding called iSync with the name input. And then that basically ends up being the actual name of the destination that messages are going to be sent to. And so under the covers, Steeltoe automatically wires this all up for you, creates the queues, creates the topics, whatever needs to be created, and then wires this all up so that now once the messages start coming in off of that location, we'll handle the message conversion and process and call this particular method handle passing in the person object. And so that is, so as you can see, it's the programming model is very, very similar. Basically what we've done is we've added this thing called bindings, instead of you declaring, for example, message queues and exchanges and all that sort of stuff. And this abstraction level that we've got here, we also think will work for Kafka and other cloud-based messaging systems as well. And so now you can see it's going to be fairly easy to write these applications using this infrastructure and tie it to easily convert it to any other kind of messaging infrastructure down the road. And then so if you look at the architecture, there's in one of the documents we've got up there, it kind of shows you a little bit about how this works. You've got this diagram here, which shows you got this underlying messaging middleware. You've got this concept of a binder that takes these are actually called channels, that takes these channels that are configured in the application. The application core is basically the handler method. And behind the scenes, the streams-based application and the Steeltoe framework wire up all of this infrastructure so that as a developer, you don't have to worry about it. It just works. And then what you're going to see in a few minutes, H. Hananil will take a minute and actually demo how this kind of programming model, then you can write these streams-based components, and then you can drop them into something called the Spring Cloud data flow, and you can combine them with off-the-shelf Java components and build these data processing pipelines for doing things like ETL-based applications or ingest or analytics or whatever it may be. And you can combine them with both Java components and .NET components and use them as kind of off-the-shelf components for building out these streams-based applications. And that's what we're releasing in RC1 going forward. So I think it would make sense now, H, if you want to take a second and add some real color to this with the data flow.
Yeah, I'll be happy to do that. I'm gonna first of all share my screen here and kind of give a brief introduction to Spring Cloud data flow. Can you guys see my screen now? What have I
Yes.
shared?
Yes.
I am sharing the wrong screen. Are you seeing, okay. Are you seeing Steeltoe documentation, Spring Cloud data flow?
Yeah, introduction, yeah.
Okay, yeah, perfect. usually I get a green border, but I have a teal border that disappears now. So anyway, Spring Cloud Data Flow is an orchestration service that you can use to deploy modern microservices. And with the abstractions and the code that has been implemented with Steeltoe Streams, it is now possible to deploy .NET applications to this environment. Spring Cloud Data Flow is, of course, available in multiple flavors. Today, we're going to look at Spring Cloud Data Flow on Cloud Foundry. And at a high level, as Dave just described, it is used to create streaming applications, data flow applications, and you can have ultimately multiple broker implementations, whether it's RabbitMQ or Kafka or something else. Currently, we only support RabbitMQ, and we can just take a look at what that looks like. So let's go to maybe here's my Spring Cloud Foundry environment, and Spring Cloud Data Flow is available as a tile, and you can install it. There are instructions in the documentation that shows you how to install it if you don't have it. And once it's installed, you can go to manage your Spring Cloud Data Flow environment, and you should see this kind of interface. And you see on the left-hand side, you have applications, streams, and other things. So first step, obviously, is to import your .NET application. Currently, we are using Docker to do this. Eventually, the plan is to support being able to deploy an archive and have the Spring Cloud Data Flow deployed to this environment. So today, you would just publish to a Docker repository and find give it the Docker coordinates, wherever you've published them. Here is an example of where I've published it. I'm not actually going to import it because I've already imported it. And once you've imported these things, they show up in this listing. Here we have 3 different applications. One is a HTTP application. Going back a little bit, Dave briefly mentioned this, but there are a number of applications that are provided with Spring Cloud Data Flow that are prepackaged that allow you to do all kinds of things, and you can now use them interchangeably with your .NET applications. So this is an example of a Maven coordinate pointing to a HTTP source, which would be the source of data. So these types of applications, when you say go to add an application, the type of application corresponds to those abstractions Dave was mentioning: the source, the processor, and the sink, which are the most commonly used. Again, each of these applications plays one of these roles of either being a source or a sink or a processor. And here I have a sample stream that I've created. And to create a stream, it's again, it uses what's called the flow interface, and you just drag and drop stuff. Or you can use DSL and CLI to do this. You don't have to use a GUI if you don't want to. And so this, what it's doing is setting up an HTTP source, which is basically something you can curl some data package into URL, and then it takes what I have here is a basic processor, which is a demonstration. I'll show the code in a little bit, but it's a demonstration of what you can do. And in this case, we're just doing a 2-upper, and it's a basic sync, and it basically logs to a file. Now you can imagine doing other things, making URL call or GET requests, or calling some other systems, and sending into some, passing them on to some other system as an endpoint. So that's how you create a stream. And
Hey, Anil, could I ask a question?
Yeah, please.
I'd like to, for just a minute, just very quickly, double click on that HTTP application. So if I understand correctly, like what Dave was showing earlier about setting up a generic web host, you created, this API. Now you have an endpoint where you can post data to it, And whenever some JSON in some format is posted to it, now it's going to forward that on to be processed.
Yes. Yeah, so this particular application is not something we've written. It's available as part of the Maven RabbitMQ pre-built application. And all it does is takes, you can post a curl command to it, to URL, and what it'll do is take it and post it onto a queue. So now that gets into the details of what actually happens when you draw this connection. It makes the queue, or in case of RabbitMQ, it's a queue, otherwise it would be a topic, is take those messages and then pass them on, and basically this component then starts reading from the queue. So that interconnectivity is achieved by just dragging and dropping these lines, or specifying it with a DSL. So here's an example of the DSL that specifies what this is, and there's no code involved. It's just a high-level abstraction for this purpose. So, and then you basically deploy it. I've already deployed it, and you can look in your applications and you can see these applications running. Now, so to kind of get into more detail about this, let me dive into the code and let's kind of look at the code sample, right? So here's the data flow sync, and here's a sample for the so I have sync in both places. Give me a second here. So this is the processor, and this is the sync. We're not gonna look at the HTTP. It's a Maven application, Java application. We don't really care. But this is just to demonstrate how simple this is. We kind of talked about the enable binding, and this says it's a processor. And when you have a processor, you can basically a processor is something that has both a sink and a source. So it has an input, and it says I'm taking an input of type string and pushing out an output of type string. Now this can be anything. These can be more complex types. Some of the other samples have something like that. And again, very simple transformation that's being done here. You can imagine more complex data aggregations, or more complex, you can imagine a machine learning algorithm running here, online algorithm, and doing something interesting with the data. But that's just as simple. That's all there is to the code. And they've mentioned the stream host. You don't have to use the stream host. You can just use a generic host. We also provide a extension method that does the exact same thing. Now, if you notice, we do pass the type in both the stream host and the generic host extension method to kind of find all these attributes. So that's pretty much all there is, these few lines of code. And if you look at the app settings, now since this is not running, I'm showing this on my local environment. When you drag those lines, this is what it's doing. It's setting your input to HTTP stream. Steeltoe stream is the name of the stream, and the name of the application in front of it is the destination, and it ties them all together in the same group. And so that's how it is able to automatically wire up these applications. And then let's take a quick look at data flow sync, and you have an isync binding here. Again, very similar here. There's nothing coming out. It's just a string coming in. And that's pretty much it. And if you see, you can configure web host, and you can do that with the generic host as well. You can basically, the stream host as well. You can do pretty much whatever you can do with the generic host. We're just writing a little wrapper and injecting the configuration and the components required.
Did you the Cloud Foundry stuff and the actuator stuff you're adding there? That's just because you're hosting the app on Cloud Foundry.
Cloud Foundry, right? Exactly. Yes.
Okay.
Yeah, you would not need that otherwise. If you, yeah. So that is all there is to the application. So let's kind of try and run this. So let's get the log flow sync working. I'm gonna pull it out, and let's look at the RabbitMQ management. Give me a second here. Management. Let me pull this out here. Let's look at exchanges and queues. So I've kind of, so when you run these applications, it creates these, and based on the configuration, creates the appropriate queues. So let me also run the processor application.
I'm going to ask a
Yeah, go ahead.
potentially stupid question. I'm not really sure. But if you're running this locally,
Yeah.
do you run some Spring Cloud data flow thing? Or
No,
are you just
so this is, you can run Spring Cloud data flow locally and test it locally. At the moment where there are some outstanding issues with Spring Cloud data flow, where you cannot deploy Docker applications when you're running locally. But all Spring Cloud data flow is doing for you is basically creating an environment you can deploy things. So you can think of it as another CF CLI, right? Like even though it's running in CF already, but there are some teams that I'm aware of that use Spring Cloud data flow as a deployment environment, because it uses the Spring Cloud deployer, I believe is the name of the thing, and it just finds a place for it to deploy your application.
okay? So Spring Cloud data flow isn't actually doing the work of listening or writing.
No.
Okay.
It is just wiring your components up together, and your application is picking which binder you're going to use. And of course, when you set it up, you need to set up let Spring Cloud Dataflow run the broker for you, right? Like you need to have RabbitMQ running in Spring Cloud. So inside my Cloud Foundry environment, you saw there's when you start up your Dataflow server, you also have that Rabbit messaging tile that comes up that's connected to this.
Right.
So yeah, so it's not a great demo, just really simple. So you can go here and just, since I don't have the Maven app running here, I'll just post some sample messages here directly onto the queue, and see it's saying it's converting testing, and so now your sync got the uppercase version of it, and it's logging it here. So that's pretty much all I wanted to show there as far as Spring Cloud data flow. Now, if we go back to the Spring Cloud data flow environment, let's see, where is this? Yeah, I've got so many windows open.
So those two windows on the left there, is that the top one is the processor that's processing?
Yeah, that's the processor, and this is the Cloud Data Flow sync. So there is currently an issue with our PES environment where I'm demoing this, where it is not showing the logs. So I kind of thought it'd be more helpful to look at the code and see what it's doing here locally anyway, and show how Spring Cloud Data Flow actually wires this up. It seems so magical to drag and drop a few things and have it all working, but that's all it does. Adds the appropriate configuration, which gets injected, and the .NET application then reads it and creates all of the infrastructure on the messaging server, and then uses that infrastructure to pass messages between the applications.
And for RC1, we're only supporting Spring Cloud Data Flow on Cloud Foundry, correct? And then
yes,
the plan is to have by GA have Kubernetes and hopefully a local development environment possibly.
Yes, definitely. Yeah, once we have our individual archives being deployed to Cloud Foundry, we should be able to run that. I mean, today you can run a stream application locally, like I just demonstrated. So local development is possible, and of course you can deploy that to a Docker and any Docker environment, any Kubernetes environment, anywhere really. But yeah, we've kind of tested Cloud Spring Cloud data flow only on Cloud Foundry at the moment.
Right, so that's only simplifying the wiring of the apps, right? I mean, that's
Yes, yes.
really, this all could be done without it. We're just showing both features there.
Yes, exactly.
Okay.
Yeah, so that's all I have. I can stop sharing now. Or somebody can stop me from sharing it. I lost my share window.
So if somebody wanted to get started with this, what would be the best way to go about that?
So sorry, say that again, Andrew.
So if somebody wanted to get started with this and really like dig deeper and learn how to use Steeltoe streams, what would be the best learning resource right now?
So Jason mentioned, the docs are available. They're live now, so we can go to docs.steeltoe.io, and there is a section under on the left hand side. You can go to stream, and has all of the documentation that's associated with it is available here. There's a getting started guide, the reference, the binder, and also a document showing how to deploy to a Spring Cloud data flow. There will be shortly samples repo posted. There are links to the samples inside these docs, but the samples are not live right this second. But shortly before the end of the day, the samples will be available. Yeah, and so that's all I have. Back to you, Jason.
Yeah, just to reiterate, Andrew, the docs are we spent a lot of time on that. We're still working through some of them, but yeah, we did a lot of work on samples, and so I think the documentation is the best path forward. There is a getting started guide for, I believe, specific for Spring. Wait, which one was that? Which one was that, Anani, that you just updated? The guide that you had, the getting started one?
Yeah, the getting started is just the Steeltoe streams. It just talks you through using initializer to generate a new project and adding the appropriate NuGets.
Okay, I'll add some links to the agenda doc that kind of will help you out, Andrew. So quick start. I'm adding it here now under the discussion feedback area. Docs too.
Out of curiosity, so it seems like a lot of the patterns in the syntax are meant to align it with the Java Spring ecosystem, especially the attribute-based configuration approach. Is there plans to also add ability to configure it using more .NET style approach, mainly how the the endpoint routing with middleware works to kind of create a processing pipeline and routing for messages within the app?
No, you don't have to use the annotations. Maybe Dave Tillman can explain better, but you can actually do this work without actually creating an annotation and actually adding your calling the appropriate methods, right? Like you can go look at the extension method and see how it's adding the enable binding, and just do that yourself. And we can create a sample. But I believe in the future we want to do something of a functional style where you don't have to use annotations anymore, and you just by the shape or the shape of the function you can determine that it's a processor source of sync. So I'll let Dave speak better.
No, you nailed it, H. So yeah, Andrew, the plan to move forward, if you look at the work that the Spring Cloud Streams team has done, is they've gone even a step further, where they now use a functional programming model, and you don't have to define things like sinks and sources and so forth. That they're under the covers, they're defined for you based off the shape of the methods and so forth. And so that's definitely on our radar to make it even an easier programming model.
Great, thanks.
The other thing too to mention is that there's, as I'm sure you're aware, Andrew, there's a lot of work going on with the within the Tanzu space and cloud native runtimes, and a lot of these same concepts are being embedded into CNR and some of these things. So some of these concepts are actually being pushed down into the platform going forward. And so we hope we're in a good position to take advantage of that from a .NET programming perspective, because we've already implemented some of the same programming constructs that are out there as well. The other important thing is the reason we've gotten interoperability here with the Java components that H mentioned is because of the way we implemented our RabbitMQ messaging infrastructure. We made it a point to make sure that the messages, the message formats, etc., are interoperable with our Java Spring counterparts. And so that's also been a thrust of all the work that we've done in Steeltoe, is that to make sure that we have complete interoperability with our Java counterparts going forward as well.
Great job, guys. Thanks for the demonstration and all the work you've been putting into this. Any other questions from anybody?
Great job, guys. That looks awesome.
It's a long time coming.
Yeah.
A lot of work.
Well, I can't wait to test it and maybe write a blog post about it.
That'd be awesome. We're also going to probably, once we're moving forward with some changes to the Steeltoe initializer or starter, start.steeltoe.io, we'll probably be adding some initializer dependencies there for streams once we get there. But we're not at that point yet, but that's coming next.
Is the idea maybe to be able to get go into a NIP starter and say, I want a sync or I want a processor, and it'll kind of wireframe that up for you?
Yeah, we're going to try to make it as easy as possible to get started with it. Yeah, so I'm assuming that's going to be part of it.
Something like that. Cool.
Yeah. All right. Anything else? Well, I don't know if we want to. Tim, do you have time to discuss or maybe even Andrew, the auto config work that was also added to 3.1? Either one of you guys have time for that? We got a few more minutes left.
I was going to defer to Andrew. That's kind of his baby.
Yeah, sure, I can talk about that. So one of the challenges that that at least me personally identified was that there's a lot of different calls you have to make to bootstrap Steeltoe components. So there's a lot of adds, use methods that you have to call. Some of them call others under the covers. So you generally have to read a lot of documentation to find out the right combination of things to make it work. And I was trying to simplify that. So we essentially copied the model that Spring Boot uses, where if it detects that certain assemblies are present in your environment, then the configuration for those is invoked automatically, and then you have the ability to override it where necessary. So this new work allows you to invoke a simple extension on your host builder method called add Steeltoe. And then depending on what NuGet packages you add from the Steeltoe collection, the configuration of those will happen automatically under the covers. And it will kind of bring in a reasonable set of defaults that it believes will work best out of the box. This should really simplify a lot of the scenarios and make adoption much more straightforward.
Yeah, excellent. Thank you for the contribution. I'm glad we could get it into this release. There are docs out there now, that Tim put together. If you want to take a look, anyone want to take a look, I just put the link in the agenda doc under community discussions and feedback. That should also kind of give you an idea. It's under the auto, I think it's under, what's it called? Application bootstrapping? Yeah, application bootstrapping is under the docs section. All right. Well, thanks, everybody. Is there any other questions or other things you want to bring up for this meeting? We have a couple more minutes left here. All right. I did want to reach out about, we are looking for some assistance with maybe some short clips or videos. We're going to be putting together most likely a YouTube channel for Steeltoe, and want to have some sort of, start adding clips there about getting started, or maybe a little bit more in depth, or it might be maybe bigger than just clips, maybe full videos. We'll be putting these meetings on there also. And, but we'd love to have some assistance there. If anybody's willing to donate some of their time to putting a video together and get some credit on there if they like. Yeah, looking forward to that. If anyone has any ideas or is willing to spend some time on that, please reach out to us on the Slack room or via email, or even GitHub if you'd like to do that from there. All right. Anything else? All right, thanks everybody, and thanks for the demos, guys. I appreciate it. We all appreciate it.
All right. See you guys.
All right, have a good one.
Bye-bye.
Bye.